This is Module 6, Lesson 12. This is Concept Development. You're going to want your straight edge. You might want some colored pencils. Now, to begin with, before we get started, I notice there is no rule. So remember, that's what our job today was, to create a rule to generate the number pattern and then plot the points. So I notice my rule is missing. Did you look at your coordinate plane? Did you label the X and Y axis? Did you label the origin? Did you look to see how the increments or the intervals of how your coordinate plane is divided up, how it's being counted? All right, so to begin with, I am going to plot the point A that's right up here. I'm going to go 1.5 and 3. So 1.5 up 3 is point A. All right, so just looking at these two numbers, 1.5 and 3, what do you notice about the relationship between X and Y coordinates? What do you think? What do you notice? 1.5 and 3. Say it out loud to yourself right now. What do you think it could be? Well, if you noticed, the Y coordinate is twice as much as the X coordinate. So the X coordinate, or you could say the X coordinate, is 1.5 less than the Y coordinate. So I'm kind of visualizing a line right now. I'm visualizing a line that's going to go through point A. So I wonder what a line could look like going through point A. Don't draw anything yet. Just imagine. Now, the line that you may have just thought of may have not been perfect in what's going to actually happen with our rule. But my question for you is, why is knowing the location of one point that falls on the line not enough to name the rule for point L? How can we base our line? How can we decide where a line is going to go just based on one point, on one coordinate pair? Well, the reason is it could be almost any line. As long as it goes through point A, it could look like a propeller, like this. It could be like this. This line could go in any direction. The line could be horizontal, vertical, or a steep line. With just one point, you can imagine drawing the line and then spinning it into many lines. So the purpose of this question is for you to realize you don't know what the rule is just based on one point. You need more information. So what if I gave you 2 and 3.5? So 2 and 3.5. Go ahead and put point B on your chart and then plot it in the plane. So 2 and 3.5 is B. So line L, the line I've been thinking of, also contains line B. So what pattern do you notice in the coordinate pairs of line L? So what do you notice in the pattern? I have 1.5 and 3, and then I have 2 and 3.5. What do you notice? What relationship could there be? How are they getting that Y coordinate? What could they be doing to the X to get the Y? The y coordinate is always, I notice, more than the x, right? At first, I thought we were going to be doubling x, but now I can see that we're adding 1.5 to x. Now, once we know the location of 2 points on a line, we know exactly where the line falls. Line L is going to be in here. So what if I decided my C is going to be 0? So it would be 0 and what? 1.5. So 0, 1.5 would be my C. What if I give my D, what if I go to 4? What would my Y be? Right, it would be 5.5. So 0 and 1.5 and 4 and 5.5. So let's go to 4 and 5.5. That's going to be our D. Now let's connect those lines. If you want to use a colored pencil, you can, or you don't. This is going to be line L. So remember, what's our objective today? It's to create a rule to generate the number pattern. So we just created the number pattern, but what rule did we decide that we were going to give it? Okay, there are 3 different ways to write this rule. So you could simply write, okay, so number 1, you could say add 1.5 to x. You could also say y is 1.5 more than x. Now remember, the reason why I'm showing you 3 different ways is maybe your brain identifies with one rule, the way I'm writing one of the rules in particular. And then a third way to write this would be y is x plus 1.5. So depending on how you like to write your rule, that's how you want to write your rule. So add 1.5 to x is probably the simplest. Y is 1.5 more than x. Y is x plus 1.5. All right. Excellent job. So now, line M. So our next line is going to be line M. And line M also is going to have point A in it. So our line M is also going to have point A in it. So record the location of A in the chart for line M. So remember, what were the coordinates for A? Well, it was 1.5 and 3. So 1.5 and 3. Okay, so we know A, and these 2 are going to share A. Is it possible that more than one line can contain point A? Yes. In order to name a rule to describe line M, what else do you need? What else do we need in order to figure out what this line is? And yes, 2 different lines can share a same point. But remember, if 2 lines share a same point, they intersect at that point. So back to my original question, though, is in order to name a rule, in order to name a rule to describe line M, what else do you need? Well, you need another point on the line. So let's write 2.5 and 5. 2.5 and 5. Now, look at this pattern. What relationship do you see between point A, so it's 1.5 and 3, and then point E, 2.5 and 5. So what did they do to get point A? Well, over here we added 1.5. Okay, so if I try to go 1.5 plus 1.5 is 3, and then if I go 2.5 plus 1.5, is 2.5 plus 1.5 5? No, 2.5 plus 1.5 equals 4. So, okay, so we know it's not going to be the exact same one. So what did they do? So in both coordinate pairs, the y coordinate is twice as much as the x coordinate. So how did they get 1.5? What's another rule that what other operation could you use for 1.5 to get 3? Well, and 2.5 to get 5. What would I have to do to add? What operation would I have to do in order to start with 2.5 and end up with 5? Well, how about if we multiply? Let's multiply x by what? How about if we just multiply it by 2? So multiply by 2, you could say double x. You could also say y is twice as much as x. Y is twice as much as x. You could say double x. You could say multiply x by 2. So I want you to go ahead and I want you to, using your rule, I want you to figure out what points F and G are. Find the coordinate pairs and I want you to plot the points and I want you to connect the lines. Go ahead and try that and come back. All right, so I usually like to throw a 0 in for my x-axis, my x coordinate, so that I can see if it's going to go through the origin or not, or how close it gets to the origin. So I ended up choosing 0, 0 and 3, 6. I drew my line M, and I was able to see that it does go through the origin. So these lines are not parallel to each other, they intersect one another, right? All right, question. Do you think there are still other lines that could contain point A? Well, sure, why not? There's so many different x coordinates that you could start with. You could even do a horizontal line through A. We could have a line that's perpendicular to the x-axis, right? We learned about rules with mixed operations yesterday. Maybe there's a line with a mixed operation rule that could contain point A. There are a lot of lines that go through that point A. So, show a line that is parallel to y, to the y-axis. What would that look like? You're right, it would look just like this. So what you're going to do now is I want you just quickly off to the side. I want you to say when x is always 1.5. So if x is 1.5 and it's 1.5 and it's 1.5 and it's 1.5, what type of rule could you create? So if x is always 1.5, so you're always starting here on 1.5, I want you to generate a rule that would have your line be perpendicular to the x or parallel to the y using the x coordinate of 1.5 each time. And see what you come up with. Okay, so this is what I came up with: 1.5 and 1.5, 1.5 and 3, 1.5, 4.5, 1.5, and 6. So my rule was x is always 1.5. And so what kind of line is created when x is always 1.5? A vertical line. Now, your last challenge here is, what if y is always 3? What does that line look like? I want you to generate some x points, and then I want you to draw the line. Come back and check your work. Okay, so if y is always 3, so I thought, well, okay, 0 and 3, 1.5 and 3, 3 and 3, 4.5 and 3. So now I've created a horizontal line. So when the y coordinate is always the same, you're going to end up with a horizontal line. When the x-axis is always the same, you're going to end up with a vertical line. All right, the last thing we're going to work with here is we're going to generate a mixed operation rule from a coordinate pair. So a mixed operation. So how about let me give you a sentence starter. Multiply x by something and then add. Multiply x by something and then add something. So what if I started with, we started with A. Let's start with point A that we started with before. So our sentence frame would look like multiply x by what? And then add what? So if we started with 1.5 and 3, what did we do? So multiply x by 1.5. What are you going to do? Come up with something. I want you to come up with something on your own. Now remember, your rule is to include multiplication and addition. So you need to make sure that after you multiply, the product is less than 3. The product needs to be less than 3 so that we still have some room to add. If the product was more than 3, then we would need to subtract to get the y coordinate. So we could multiply by 1.5 by and get a product less than 3. So what do we know? What do we know about multiplication? So if you multiply it by a number greater than 1, your product is going to be greater than 1. If you multiply by a number less than 1, your product is going to be less than what you started with. So think about that for a second, and I want you to actually write something in. Okay, so did you try something? That's the big idea. Did you try something? All right, so let's just play around with this. Let's see what happens if we multiply 1.5 times 1.5. Well, that becomes 3 halves times 3 halves, which becomes 9/4, which ends up being 2 1/4. Well, yay, 2 1/4 is less than 3, right? Okay, so we can have that, multiply x by 1 1/2. But so far our rule says multiply x by 1 1/2 and then add. What do you think we should add to 2 1/4 so that our y coordinate is 3? So what could you add to 2 1/4 to get 3? Yes, you could add 3/4, right? And then that would give you 3. So multiply x by 1 1/2 and then add 3/4 is going to give me my y coordinate, right? So multiply x by 1 1/2, then add 3/4. So based on this and add, that's right, 3/4. All right, so I want you to name 2 more coordinate pairs that would fit on this line, that would fit with this rule. Okay. Go ahead and try to give me 2 more coordinate points. Now remember, I just throw numbers out there. I might try 0. I might try 1. I might try 2 just to see where I end up. So go ahead and try that. Try 1 1/2. So go ahead and try and see what you get. But don't forget, what you're trying to do is your coordinate points have to sit on a line that are going to go through 1 1/2 and 3. All right, so what I did is I started with 0, and I went 0 times 1 1/2 is 0 plus 3/4 is 3/4. So 0 and 3/4. And then I thought, well, okay, let's try 1. So 1 times 1 1/2, then add 3/4 gives me 2 1/4. I plotted my point. Then I went 1 1/2. And I knew I was going to include this a in there. So then I tried 2. 2 ends up being 3 3/4. So that's how I generated my new line. So that is the end of our concept development. So our big idea was, can you generate a rule based on coordinate pairs? Now you absolutely need more than just one coordinate pair to know where that line's going, correct? All right, that is the end of concept development for Module 6, Lesson 12. You now have problem set. You have your exit ticket, and then you have your homework. Be sure to check back and finish up your subtraction of decimals, and check back for Module 6, Lesson 12, problem set debrief.